Yes. Today we are going to do moments. M1. What is moment? It is turning effect of a force. Example. If we have a rod here of length L, and if we have a pivot here, which is very important to have a pivot, and if we apply a perpendicular force here, and in M1 all the forces are going to be perpendicular, this is the pivot, my fingers holding the pen. If apply a force here, it is going to turn. As you see, it is going to turn. Not move, but turn. This effect is called the moment. And moment can happen in two directions. Either anti-clockwise or in this case, again, if we apply a force perpendicular to the length, to the rod or to the plank, as in this case, it is going to turn in the clockwise direction. So, moment is equal to distance times perpendicular, distance times force, which is perpendicular. And you have to remember that we have to have a pivot so that the rod or the plank turns, do not move. In moment, we don't care about the movement. We only care about the turning. And it happens in two directions. Either anti-clockwise or clockwise. Either anti-clockwise or clockwise. Now, in our questions, unless stated otherwise, pivot will be the leftmost point on the rod or plank. In M1, we have two types of rods or planks. Uniform rod or non-uniform rod. What is uniform rod? then that distance has to be equal. And for non-uniform rods, center of mass is not at the midpoint. Yes. Now, modeling a rod. How are we going to write down the forces on the rod, on the plank? Modeling forces on a rod. Say that this is a uniform rod standing on two pivots and a painter standing on the rod. This is a very famous painter for moment questions. You will see that painter a lot in the questions. It is going to move along the rod so that the moments are going to change. Okay? Now, this is the rod, a uniform one. These are the two pivots P and Q. And this is mg, weight of the rod, and say that we have the famous painter here. Okay, this is our famous painter moving along the rod. Also, this is the mass of rod. This is the weight of the painter and its weight here. Mass of the painter is mp, mass of the rod is m rod. Okay, let's study the forces on this rod. If you have such a question, you are going to draw a line representing the rod, and this is the normal reaction at the pivot P. This is the normal reaction on the pivot Q, and this is the weight of the rod at the midpoint of the rod, and this is the weight of the famous painter on the rod. These are the forces. And again, remember, you have to remember that during this M1 course, I am going to teach you to take the moments from the leftmost point. It's not a rule, but it's my choice. In M1, you can change the points where you can get the moments, you can calculate the moments, but during my lesson, unless stated in the question, I am going to take the moment about from the leftmost point. Okay? And I'm going to solve an example with numbers on it. I'm going to teach you how you are going to get the moments, but that's a rule written by me. That's not the rule for physics. I am going to solve M1 questions, M1 moment questions, taking the pivot from the leftmost point. Now, this is a typical case with the pivots. Now we have another case with tensions. Say that we have another rod here and two strings holds the rod and again mass of rod times G gives the, and again let's have the painter here. This is our famous painter. How are we going to write the forces? We are going to represent the forces saying that this is tension on string A, this is tension on string B, mass of the rod times G gives the weight of the rod, and mass of the painter times G gives the weight of the painter. This is how we are going to represent forces on this rod. This will be the first step of our solution. From the diagram, we have to draw we have to represent each force on a number line representing the rod or the plug. Now, calculating the moments on a rod or plug. First thing to do is to choose a pivot point on the rod, and what Mr. Umut told you, the pivot point is going to be the leftmost point on the rod, unless stated otherwise. And what is the second rule? Moment is equal to force times the distance, F times L. And this distance is the distance from the pivot point. And the directions are important, either in the anti-clockwise direction, or the moment is going to be in the clockwise direction. Yes, let's have an example. Revising all the things that we learned up to this point. Example. A rod of length 6 meters and mass 20 kilograms stands on 2 pivots as shown on the diagram. Calculate the moments about point A. Mass of the painted on the rod is 85 kilograms and rod is uniform, which means its center of mass is at the midpoint. And this is the diagram. This is the rod AB standing on 2 pivots, P and Q. And it is given in the question that AP is 1.2 meters, QB is 0.8 meters, and painter is on the rod one meter from point A. Let's draw the forces and calculate the moments. Solution. Draw a straight line representing the rod. What is the first force that we see on the rod? It is the painter with mass 85 kilograms, which represents a force of 85 G pointing downwards. And what do we have here? And the distance here from point A to the painter is 1 meters. Do not forget to write the distance. It is very important to write the distance. Remember, moment is equal to force times the distance. And what do we have? We have a normal reaction force of the pivot pointing upwards from point P. This is RP. And what is the distance of P from point A? It is 1.2 meters. We have another force here from the midpoint of the rod. It is the mass times the gravity, so it is the weight of the rod pointing downwards from the midpoint of the rod. Why from the midpoint of the rod? Because it is uniform. If it is uniform, the weight stands, the weight is at the midpoint. So we will have, what is the mass of the rod? It is 20 kilograms. So the weight of the rod is 20 kilograms and it is 3 meters from point A. Why 3 meters? Because the total length of the rod is 6 meters from A to B, as you see here. And because it is at the midpoint, because it is uniform, the distance from A to the midpoint is 3 meters. Remember, the length of the rod is given as 6 meters. And we have another force here, the normal reaction force at the pivot Q, and let's rename it as RQ, normal reaction force at point Q pointing upwards. And what is the distance from A to the reaction force which is at point Q? If this is 0.8 and if the total distance is 6 meters, it is very easy to find the distance from A to Q. From Q to B it is 0.8 and the total distance from A to B is 6. So from A to Q the distance will be 5.2 meters. Remember, we are going to take all the distances respect to the pivot point. And our pivot point is going to be always the leftmost point there. The point on the left. The first point. Okay? Unless stated. So from A to Q, this is point P, this is point Q. From A to Q, the distance is going to be 5.2. How did we find it? The total distance was 6. From Q to B is 0.8. 6 minus 0.8 becomes 5.2 meters. So, moment about point A, or we can write it as MA, which means moment about A. We have two directions for the moments. We have the clockwise ones, also we have the anti-clockwise ones. So first of all, let's calculate the anti-clockwise moments about point A. This is our rod. Point P is the pivot point. And P tries to turn the plank, the rod AB, up in the clockwise direction, in the anti-clockwise direction. What is the distance? 0.2. What is the force? RP. So first anti-clockwise moment is force times the distance, 1.2. We have another force here, RQ, which tries to turn the rod in the anti-clockwise direction. That is also RQ. RQ tries to push up, tries to turn this rod AB in the anti-clockwise direction. What is this distance? 5.2. What is the name of the force? RQ times 5.2. We have two forces that tries to turn the rod AB in anti-clockwise direction, and we calculate their moments. What are the clockwise moments? We have two forces pushing down the rod AB. Remember, pivot is at point A, and this 85G weight of the painter pushes the rod AB downwards, which makes the rod turn in the clockwise direction. What is its distance from A? It is 1 meter. The force is 85G times 1. And we have another force here, which was the weight of the rod, which acts at the midpoint of rod AB, which also pushes the rod AB in downwards, which tries to turn the rod AB in clockwise direction, and its distance is 3 meters and force is 20 G. So the total moment of the weight of the rod is 20 G times its distance, which is 3. These are the anti-clockwise moments, and these are the sum of the moments in the clockwise direction. Do you have any questions? This is a very important example. I am checking the messenger for your questions. If you have questions, just ask now. Yes, we had a question from Mustafa. Look here. We have 2 pivots. That means we have 2 reactions. We don't have any strings here. If you don't have any string, that means you don't have any tension. To have a tension, you need to have strings. Here we have only pivots. If you have pivots, it means you have 2 reaction forces. If you have a single pivot, that means you have a single normal reaction force. But if you have tensions, if you have strings, that means on that example you are going to have tensions. That is very easy thing to see. Strings, tensions. Pivots, reaction forces. That's it. Now, this is going to be the most important word for moment questions. Now we are going to have the title of the day, the question of the day. Very, very, very important. Equilibrium. Very, very important. Means sum of forces is equal to 0, and second thing about equilibrium, sum of moments must be equal to 0 as well, which means anti-clockwise moments must be equal to clockwise moments. 2 rules must be okay to have a complete We have two pivots here, P and Q. Remember from the last example, this was 1.2 meters, this was 0.8 meters. AB, the length AB was 6 meters. Mass of AB was 20 kilograms, I think. And the famous painter was here with mass 85 kilograms. And this was the uniform rod that we studied. And the question is, find reaction forces on pivots P and Q. What is RP and what is RQ? Now, let's redraw the shape, the diagram that we already drew in the last example. We had RP here, we have RQ there, 85G there, 20G there. This is point A, this is point B. The distance from A to RP, reaction force on P is 1.2 meters. From A to the painter is 1 meters. From A to the midpoint of rod is 3 meters. And from A to Q we had 5.2 meters. Let's apply rule number 1. Sum of forces must be 0. We have Fy, forces pointing up and forces pointing downwards. And because the system is in equilibrium, we have to have the sum of forces as 0. Rp is up, it is positive. Rq is also up, it is positive as well. 85G is pointing downwards, and we have 20G pointing downwards as well. So Rp plus Rq is equal to 105G. This is the first information that we get from the first rule. For equilibrium, sum of forces must be 0. And second step is to take the moments about point A. Always from point A. Always. And we have anti-clockwise moments which must be equal to clockwise moments. Why? Because we have to have equilibrium. To be able to have equilibrium, sum of moments in the anti-clockwise direction must be always equal to the moments on the clockwise direction. So, from A, this is pivot A, RP is pushing up in the anti-clockwise tries to turn this rod in the anti-clockwise direction. So it is going to be 1.2 times RP, normal reaction force of pivot P. And same case for RQ. RQ again pushes up in the anti-clockwise direction, and the distance is 5.2, and the force is called reaction force on point Q. These are the only forces causing an anti-clockwise moment about point A. You have to write that one. You have to write that one. It means you are going to take moments about point A. And for clockwise moments, if A is the pivot, 85G, the weight of the painter pushes downwards, which makes this rod tries to make the rod turn in clockwise direction, and distance is 1 meter. So it is going to be 85G times 1. And we have another force here, 20G, which tries to turn the rod in the clockwise direction as well. And its distance from A is 3 meters. So the moment of the weight of the rod is going to be 20G times 3. So 1.2 RP plus 5.2 RQ is equal to 85G plus 60G. 1.2 RP plus 5.2 RQ is equal to 145G. Now we have two unknowns and two equations. How are we going to solve them? We are going to solve them by simultaneous equations. RP plus RQ is equal to 105G. 1.2 RP plus 5.2 RQ is equal to 145G. So let's multiply the first one by 1 minus 1.2 minus 1.2 RP minus 1.2 RQ is equal to minus 126G. 1.2 RP plus 5.2 RQ is equal to 145G. Add them, RP is cancelled, and 4RQ is equal to 19G. RQ is equal to 19G over 4. RQ is equal to 19 times 9.8 divided by 4, a total of 46.55 newtons. Remember, these are the forces, and RP plus RQ is equal to 105 G. We already know the force here. For RQ, RP plus 46.55 is equal to 105 G. RP is equal to 105 G minus 46.55. RP is equal to 982.45 newtons. I am going to take the picture and send it to you with Messenger. Yes, let's solve a couple of questions from your book. Question 7 on page 135. Open your books. Please open your books. 135, question 7. Don't worry, I am going to solve so many questions for you from this topic moments. This is the last topic in mechanics. Please, page 185, page 135, exercise HC, question 7. Yes, a uniform AB of length 5 meters, mass 60 kilograms, has a load 40 kilograms attached at B. Remember, the weight of the rod is at the midpoint because it is a uniform one. I am going to solve non-uniform questions as well. Don't worry. But this is a uniform one. So its mass, its weight is at the midpoint. And the tension in the wire C there, this is tension A, and this is tension C. Tension in the wire C is, say that this is T, so this is 40. Why? Because the tension in the wire C is 4 times the tension in the wire A. I called it T, so this is going to be 40. It's because it is 4 times. By modeling the beam as a uniform rod, this is a rod, uniform one, and its weight is at the middle. Calculate the tension in wire C, the distance CB. Also, we want that distance. Now, let's write the forces which are on the rod. This is 60 G at the center. The total length is 5, so this is going to be 2.5 meters. Because it is at the middle and the total length is 5. How do I know it? Because I read the question. And we have T here, and we have 40 there. And we have also 40 G at point B. Any questions? Do you have any questions? Yes. Now, what was rule number 1 for equilibrium? The real rule says that sum of net forces must be what? 0. We have two forces acting up at A and C, and we have two forces pointing down. So a total of 5T there, 100 G there, tension is equal to 20 G, and tension C is equal to 40, so it is going to be 4 times 20 G, tension C is equal to 80 G. Do you have any questions? No? No messages from messenger, so I am going to carry on. This is the answer for part A. What was the question in part B? The distance CB. We are looking for that distance CB, and it is given in the question. Now I am going to take moments about point A. Moments about point A. And for equilibrium, anti-clockwise moments must be equal to clockwise moments. Here, this pushes up, but it is at point A. What is the distance between point A and tension A? 0. Because it is at the point A. Tension A acts at point A. So although it has an anti-clockwise moment, although it has a force here, it doesn't have any moment, because its distance from A is what? 0. So what is moment? Force times distance. So it is going to be 20 G, but its distance is 0. Because we are taking moments about A, but it is on A. So its distance, the distance between tension A and point A is 0. And we have another force here pointing upwards. Tries to turn this rod AB in anti-clockwise direction as well. It is C. Do we know the direction? No, but we call it L. And what is the force? ATG. Remember, moment is what? Force times. Now, we have clockwise moments here. What are clockwise moments? We have the 60 G pointing downwards. What is this distance? 2.5 times 60. Here, what is the distance here? It is 40 G. What is its distance? 5 times 40 G. This is 0. L times 80 G is equal to 150 G, 200 G. So L times 80 G is equal to 360 G. L is equal to 360 G divided by 80. L is 4.375 meters. So From A to C, it is 4.375. From C to B, this is the CB will be 5. The total distance minus 4.375, which is 0.625 meters. That's the end of the question. This is the answer for question 7 on page 135 from your M1 books. Now, I think we had a connection problem. Now I am going to continue with another question. I am going to solve a non-uniform example on page 138. I am going to solve question 4 on page 138. It is a non-uniform rod. Now, page 138, question 4. A non-uniform rod AB of length, again we have a rod AB, its length is 5 meters and mass 15 G, 15 kilograms. The weight is 15 G, but we cannot put the weight at the middle. We don't know its place. It is somewhere near the center of the rod, but not at the center of the rod, because it is non-uniform. That means we don't know if it knows that non-uniform means we don't know the exact place of center of mass. Say it is somewhere here. $15 G. Rest horizontally suspended from the ceiling by 2 vertical strings attached to C and D, where AC is 1.1 meters. This is C, 1 meter from A, And the other one is D, which is 3.5 meters from A. This is D, and this is 1.5 meters from B. How do we know that? If it is 3.5 meters from A, we don't need that. Sorry, we don't need that. It is 3.5 meters from A. Given the center of mass is at E, call this point E. Find the magnitudes of the tensions in these strings. Here we have tension C and tension D. And AE is 3 meters. It is given in the question. So, for part A, let's apply our equilibrium rules. 1. F net must be what? 0. So, tension C plus tension D minus 15G is equal to 0. Tension C plus tension D is equal to 15G. And anticlockwise moments, sum of moments must be equal to 0, or anticlockwise moments must be equal to clockwise moments. So, here, moments about A. We have tension C forcing up, tries to turn in anti-clockwise moments. And what is its distance from A? It is 1. 1 times tension C. Do we have another one? Yes. We have tension D, again pushing up, trying to turn the rod AB in the anti-clockwise direction. And what is its distance from A? Its distance from A is 3.5 meters. And its name is tension D. We have all the anti-clockwise moments, and we have a single moment in the direct single moment which has a clockwise direction. It is due to the weight 15G, which is 3 meters from point A. So it is going to be 3 times 15G. So TC plus 3.5 TD is equal to 45 G. 2 unknowns, 2 equations. TC plus TD is equal to 15G. TC plus 3.5 TD is equal to 45G. So, put a negative sign there and add them. TC is cancelled. We have 2.5 TD is equal to 30G. So tension at D is, by the help of our calculator, it is going to be 30 times 9.8 divided by 2.5 is equal to 117.6 newtons. Remember, these are all forces. And TC plus TD is equal to 15G. TC plus 117.6 is equal to 15G. So TC is going to be 29.4 newtons. This is the answer for part A. Let's carry on with part B. B. Let's read B. When a particle of mass 9 kilograms is attached to the rod at F, the tension in the string at D is twice the tension Yes, we have to put another force here at point F. So, we have TC there, we have TD there, we have 15G there, and the tension in the string D is twice the tension in the string C. If this is T, this is 2T, twice of it. And we have F, I don't know, call it there. We don't know actually its place, but we know that its weight is 9G. This is point A, this is B, this is E, this is C, and this is point D. But we don't know the distance between A and F. Call it X. Do we know the distance between A and C? Yes, it is 1 meters. Do we know the distance between A and D? Yes, between A and D it is 3.5 meters, already given in the question, and between A and E it is 3 meters. So, calculate the distance AF. Again, apply our two rules for equilibrium. F net is equal to 0. T plus 2T is equal to 15G plus 9G. 3T is equal to 24G. T is equal to 8G, which means this is equal to 8G, and that one is equal to 16G. Now, anti-clockwise must be equal to clockwise moments. Moments about A, 1 times 8 plus G, 3.5 times 16G is equal to 3 times 15G plus X times 9G. So 8G plus 56G is equal to 45G plus 9XG. $64G is equal to 45G plus 9XG. Cancel all G's. 64 is equal to 45 plus 9x. 19 is equal to 9x. X is equal to 19 over 9, which is, leave it as like that, some meters. That's the answer. Tomorrow we are going to with the moments. We have a very important topic there, tilting. Tomorrow a moments will be finished, which means M1 will be finished. See you tomorrow at 1 o'clock with tilting. That's the end of the lesson.